Okay, now I want to take a look at a couple of examples of simplifying complex fractions that involve more than one variable. Okay, so in this first example, I have ab squared over 2c, all divided by a divided by 4bc. So there are a couple ways you could do this. There's a fraction divided by a fraction here. So you can just multiply by the reciprocal of the divisor. We've been working on this multiplication by one thing, so I want to do it that way, and then I also want to do it with the multiplication by the divisor. And if I'm looking for the LCD of the little denominators, what are they? Okay, so we've got the 2c and the 4bc. Okay, so looking at those, I'm looking at the numbers 2 and 4. So the least common multiple of 2 and 4 is 4, right? And what are the other factors? We've got b and c, right? So 4bc is the LCD of those two. Okay, so that's what I'm going to multiply the numerator and denominator by, right? 4bc and 4bc, numerator and denominator. Okay, so when we do that, in the numerator, 4 over 2 is 2. The c's cancel, and I'm left with ab squared times b, which is b cubed, ab cubed. And then in the denominator, the whole thing goes away, right? I'm just left with a. Oops, looks like I forgot a number up here, right? What did I forget? Just looking at that again. So I was concentrating on the b squared times b, but I forgot about the 2, right? So 2ab cubed in the numerator and a in the denominator. Okay, and look what happens there. A's cancel. So I'm left with 2b cubed. Okay, and I would also say, take note of the restrictions, right? I just canceled an a out, so a can't be 0, and a was part of the big denominator to begin with, so a can't be 0. And b and c were both part of denominators in the original expression, right? So I would say b can't be 0 and c can't be 0 either. Okay, so some domain restrictions. Okay, so now I want to look at this in that other way, right? So if we take the numerator of ab squared over 2c and we multiply it by the reciprocal of the divisor, so 4bc over a, start canceling things. So I have a over a, right? 4 over 2 is 2. C over C cancels, right? So don't forget about that 2 again. So I have 2 b squared times b is b cubed, right? With all of the same restrictions, right? A can't be 0, b can't be 0, c can't be 0, right? Okay, yeah, so we get the same thing either way, but sometimes when you have just a single fraction divided by a single fraction, it's more convenient to multiply by the reciprocal of the divisor. All right, one more. 1 over x plus 1 over y, all divided by x squared minus y squared, all over xy. Okay, so the first question I'm asking myself is, look at all the little denominators, right? What's the LCD of those, right? Well, x, y, right? Those are all the factors that exist there. Okay, so if I multiply the numerator and denominator by xy, what am I going to have there? So I'm multiplying this through. In the first fraction, the x's cancel, and I'm left with y. And in the second fraction, the y's cancel, and I'm left with x. Right? And downstairs, the whole thing of xy cancels, and I'm left with x squared minus y squared. So the only other thing I see to do here is that the denominator of x squared minus y squared factors. It's the difference of squares. X plus y times x minus y. Okay, and y plus x and x plus y is the same thing, right? So we can cancel that factor and we're left with 1 over x minus y. All right, so now be careful here. What did we cancel out? X plus y can't be 0, right? So x can't be negative y. And I would also say x can't be 0 and y can't be 0 based on our original expression, right? You always have to go back and look at the original expression for a domain restriction. Okay, very good. So you see how all of this can pop out real fast without finding the LCD. And by the way, just a reminder on this, I like to just be able to kind of see what cancels. Like, you know, when I'm distributing that xy through, x's cancel, I'll be left with y. In the second fraction, y's cancel, I'll be left with x. And it's a little bit cleaner than writing out the step of actually distributing that to each numerator. But if it helps you, do it, right? So if you have 1 over x plus 1 over y divided by x squared minus y squared all over xy, and we're multiplying, right, through by the xy. Yes. So my point is, you're really distributing the xy to the numerator, right? So you're saying xy divided by x plus xy divided by y, right? All over, and down below here, that just goes away, right? X squared minus y squared. Okay. But we can see in the numerator, the x's cancel here and the y's cancel here. So if it's helpful for you to put it in the numerator like that and to write that step, absolutely do it. If it's not helpful, sometimes it's just even helpful to use your fingers, right? Kind of what's being canceled where, and tackle it that way. Okay, so I just wanted to bring that to light. Don't be afraid to write out additional steps there if it's really helpful for you. Okay. Here I'm finishing the factoring. We get the same thing, right? The 1 over x minus y with the domain restrictions.